Experienced professionals in the petroleum industry strive to maximize the useful life of their oil and gas fields with new technology. Today more than ever, you must take advantage of technologies and services that can optimize your drilling operations and help you get the highest returns from your investments. Sperry Sun is committed to bringing effective drilling and production solutions to the industry. Solutions for the kinds of challenging conditions you face both in the borehole and in the boardroom. Our new Geo-Pilot rotary steerable system now enables you to reach targets that were logistically and economically unattainable in the past. In collaboration with the Japan National Oil Corporation, or JNOC, Sperry Sun has designed a bit-tilting rotary steering technology that enables you to steer the wellbore while simultaneously rotating the drill pipe. This remarkable system is fully integrated with all Sperry Sun logging while drilling sensors, the components that you have grown to trust because of their quality and reliability. Sperry Sun's unique Geo-Pilot rotary steerable system enables you to drill far more complex directional and extended reach wells than ever before. Targets that only a few years ago were thought to be impossible to reach with conventional steering assemblies. The Geo-Pilot rotary steerable system provides you and your team of engineers, geologists, directional drillers, and LWD operators with valuable real-time continuous steering information at the surface where you need it the most. It's an automated drilling system that puts you in the driver's seat. A technology solution that can translate into significant savings in time and money. The Geo-Pilot self-correcting steering technology enables you to maintain the desired tool face and percent bit tilt while maximizing drill string RPM and increasing ROP. That's because unlike conventional steering assemblies, the Geo-Pilot system does not rely on the axial forces of sliding to steer the bit. Steering by sliding is typically accompanied by significant drag, which can limit your ability to transfer weight to the bit. Instead, Sperry Sun's Geo-Pilot system is steered by tilting the bit in the direction that you want to go while rotating the drill pipe. When you don't wish to steer, you simply instruct the tool to turn off the bit tilt and point straight. Since there's no sliding involved with the Geo-Pilot system, the traditional problems related to sliding such as stick slip, whirling, differential sticking, and drag problems are greatly reduced. With Sperry Sun's Geo-Pilot technology, the wellbore has a fluid profile as you change course. Dog legs are minimized, and the effects of tortuosity and other hole problems are significantly reduced. In fact, with the Geo-Pilot system, you optimize your ability to complete your well while improving your ROP, prolonging bit life, and minimizing casing wear. Sperry Sun's Geo-Pilot rotary steerable system has even more advantages. For instance, hole cleaning characteristics are greatly improved. That's because the continuous rotation facilitates better cuttings removal. Unlike positive displacement mud motors, our design has no traditional elastomer motor power section, a component subject to wear and environmental dependencies. By removing the need for a power section with a Geo-Pilot system, torque is coupled directly through the drill pipe from the surface to the bit, resulting in potentially longer bit runs. Plus, Sperry Sun's Geo-Pilot technology is compatible with virtually all types of continuous fluid mud systems. The concept for Sperry Sun's Geo-Pilot rotary steerable system is unique. Essentially, it involves the controlled deflection of a one-piece shaft between the bit and the top of the tool. Made of high-strength stainless steel, this shaft is hollow to allow drilling fluid to flow through it unrestricted. There are no articulations that may be prone to failure. A compact, rugged bending unit contained within the non-rotating high-side referenced housing imparts a controlled deflection to the shaft via the rotating of two eccentric rings. Specially designed rotary seals inside the housing keep drilling fluid out and lubricating fluids in. A balanced piston achieves pressure compensation on the inside of the rotary seals. Here's how it works. After the pumps are turned on, the tool face reading is sent up from the LWD survey probe to the surface display. The string is then oriented to the desired tool face by turning the drill pipe until the desired tool face is seen. After a short pause, the drill string is rotated, The eccentric rings are engaged from above and below by two clutch-controlled actuator systems. By engaging one or both of the actuators, the rings are rotated together or independently to push the shaft off the center line of the housing, causing the shaft to bend and the bit to point in the selected tool face, measured by the MWD. An upper cantilever bearing, radial support bearing, and a lower focal bearing support the shaft section that runs through the housing. When the eccentric rings bend the shaft is bent between the upper cantilever bearing, which keeps the shaft from bending above it, and the lower focal bearing, which allows the bit to tilt in the opposite direction of the bending direction. The focal bearing allows the bit to tilt in any desired direction and rotate freely while transferring most of the bit weight into the housing, allowing the shaft to be slimmer and more controllable. The reference stabilizer features a series of rollers that contact the formation wall to slow the turning of the housing with the shaft while drilling. Since the rollers exert only a slight load, the axial motion of the tool is undisturbed, and the housing rolls at a speed that the bias unit can keep up with while drilling. The shaft bends like a bow and tilts the bit in the direction and magnitude that you want to drill. By turning the pumps off and then on, you have total control of the tool face selection. The deflection can be turned on or off at the directional driller's discretion. For maximum operating life and reliability, the Geo-Pilot system's bearings, seals, and other internal moving components are all immersed in lubricating oil. And since the tool operates independently of wellbore fluids, there are virtually no mud compatibility problems. An at-bit inclination, or ABI insert, continually measures the housing inclination near the bit and the angular position of the housing or housing tool face relative to the high side of the hole. The data is relayed to the Geo-Pilot system's onboard computer and sensor system located just below the cantilever bearing inside the housing. While drilling, the housing will slowly rotate to the right due to the small amount of torque that is transmitted from the shaft through the support bearings to the housing. This motion causes the bit tool face to move out of the desired position. The electronic control module senses this change and keeps the bit tool face on target by automatically rotating the eccentric rings of the bias unit to the left. This counterclockwise rotation, in turn, causes the bit tool face to track back to the left with the eccentric rings. The bending unit responds quickly, correcting the tool face back to the left to keep both the tool face and deflection on target, providing near-perfect steering control. In addition to having its own internal electronic controls and sensors, the Geo-Pilot system interfaces with our LWD system. While you drill with Geo-Pilot technology, our LWD system pulses detailed steering information about at-bit inclination, tool face, and deflection back to the surface, along with standard formation evaluation data from our standard sensors located above the Geo-Pilot system. A specially designed pressure compensator internally maintains a slight positive pressure across the rotary seals. It features an integral displacement transducer to provide an indication of low compensation volumes to the surface system. Other advanced sensors, all powered by a long-lasting internal battery, monitor bit position, string RPM, and internal tool parameters. Plus, the Geo-Pilot system is integrated to our Insight Rig information system, making the tool even easier to control. The Insight system features an enhanced driller display unit that enables you to see the current status of the tool face and precisely what the Geo-Pilot system is doing downhole. This capability maximizes your wellbore steering quality and provides the best steering control possible for your well. With operational costs on the rise and dollars at a premium, you need to make the most of your valuable assets and extend their reach. As you can clearly see, Sperry Sun's Geo-Pilot rotary steerable system is the technology solution to help you do that. It's the latest, most sensible system on the market, with the features you really need to make your next rotary steerable application a real success.